Hello and welcome to my new video. Today I'm gonna show you how to determine a sentiment in a commentary using ML.NET. Before that, make sure you subscribe to my channel because I'm gonna upload more and more videos and ring the bell to be the first who sees them. Thank you for this. Now let me show you what we have today. We have two projects. The first one, which is console application. In this console application, we have a dataset which was taken from the Microsoft documentation. In the dataset, we have a commentaries from IMDb. The commentaries are whether positive or negative. If they are positive, the value is 1. If they are negative, the value is 0. To the other project, we have a typical .NET MAUI application, but we will look at this later in the video. Okay, what we need to be able to determine sentiment in a commentary. First of all, we will need the ML context. The ML context is an entry point for all operations in the ML.NET. It is something like DB context in the Entity Framework core. Now, since we instantiate the ML context, next we will need to take the path to our file with the labeled data. To take this path, we will use this command. Well, I'm using path combine and taking the environment current directory, which, as you know, is not this directory. That's why I'm using a relative path to take the file. Now, since we have the path to the file, next we will need to take the data from this file. The data is represented as an iData view, and it's from mlcontext.data.load from a text file. Well, this is used when we have a file, like in our case, but if we have some collection, we can use load from enumerable. Now, as you see, this method requires some model in which to map the data from the file. The model that we will use will be called input model. Now I'm gonna create it just now. Let's say input model. This input model will consist of two properties. First property is the sentiment text, and the second one is the sentiment itself, which means the commentary is positive or negative. As you can see here, we have attributes. The first one is called load column. We have it on the both properties. This load column determines the position of each column. On the second property, we have the column name. Well, as you know, in the ML.NET, the prediction label column must be named as label. That's why we're using this attribute here, column name, and we name the sentiment as a label. Now, since we have our input model, we will have to take our data and we have to split it into parts. Now we are using the mlcontext.data.trainTestSplit, which means that we will take our data and we will split it in these parts. The first one, which will be the test part, which will take only 20% from the data that we have now, and the other 80% will be used to create our model. Like you can see here, this test fraction, it means that it will take 20% of the data for the test. Now, since we split our data, the next thing that we have to do is to start with our training pipeline. Our training pipeline will consist of featureizing the text, which means that our columns, which are text, for now the commentary is a text, will transfer to a numbers because, as you know, computers work better with numbers than with text. We are using this and we name it a features. After that, we will need to append our trainer. Our trainer will be taken from the mlcontext.binary classification because this is a binary classification problem. we need to determine whether something is 0 or 1. The best way to do this is to use binary classification. And you can see in the ML context binary classification we have trainers. In this trainer there's a lot of trainers, but since I checked in the documentary, this trainer is this model trainer is the one that gives the best results for our problem. Now since we create our pipeline, it's time to fit our data. Fitting the data means that we will train our model. You should keep in mind that ML context is using lazy loading. That means the data will not be loaded, nothing will be done until we fit this data to our model. Now since we fit the data in our model, we will need to evaluate our model. For that, we will use the test set that we created before. It will be like this. As you can see here, we're using the transform and we're using the test set, which consists of 20% of our data. After that, we will need the metrics. The metrics are used to evaluate whether our model is good or bad. Now I'm gonna put here 3 console lines to check our method. Now let's start it to see what will be the result. Now you see the accuracy of our method is 74%. Okay, this is I think it's good for our test. Well, after that we need since we evaluated our model, we need a prediction function that will have one method called predict, which we will use, as the name says, to predict whether the commentary is good or bad. Now we will need this prediction engine, and this requires another model which we will call output model. In this output model we will have our metrics. I'm sorry, not our metrics, we have our prediction there. Now you can see output model. Okay, let's make it public and let's put the 3 properties that we will have. The most important for us is the property called prediction, in which we have the predicted label. Well, the prediction will tell us whether the commentary is good or bad. Now since everything is okay here, I think we can continue. Now let's give us some example to test our model. Let's see, input model sample will be equal to new input model, in which we will have a text. Let's say this is the best movie I have ever seen. Okay, and from this prediction function we use the predict method to predict the sentiment. Okay, let's make it like this. I'm sorry, should be sample here, and I want to see the result. That's why I will go to the output model and I will inherit the input model to be able to see what is the text and what is the result in this text. Now we can start our program and you can see our text, this the best movie I have ever seen, is a negative. Yeah, now it's good. This is the best movie I have ever seen with the probability of a 0.63% of a 63%. Well, this is not the best result, but I think for our demo is good. Okay, since we've created our model, it's time to give an example in a real-life application. For this purpose, I have here a .NET MAUI application in which I copied our model.zip file. So I'm not gonna show you all the features of the .NET MAUI because this is not the subject of our example today. I will just show the things that we need to use our model. To use our model, first we need to open the MAUI program CS and we need to add the following code. This is the same like when you are registering something in the dependency container of a ASP.NET Core application. Here we need to register prediction engine pool, which we will use to predict sentiment in the commentary. You can see that this engine pool accepts input and output model. This is the same model that we have here, but I created the new ones in our application. Okay, after that we need to go to our service where we have added a reference to this engine pool, and we have one simple method which predicts the sentiment in the commentary. Now let's start the project and test it. Okay, this is our application. I like your movie. Okay, you can see that result here says that we have a 76% this to be positive. It was a nice movie. This has a 52% to be positive. It seems that our model is working. Now let me say it again. What we need to use a model in a real life application. First we need a copy of our model. We need to register it in the startup class, in the dependency container, and after that if we want to use it, we need to add it to the service. After that we have just one method, which is predict method, and that's all. Thank you for watching this video. Have a good day. Don't forget to subscribe, to ring the bell, write some commentary, and I'll come back with a new video. Thank you and bye bye.